So in this video, we'll quickly look at how to calculate a confidence interval from a given sample. Often we look at range of dimensionalities. For example, what we looked at in this diabetes data set. We may not know all the values of these observations, right? We may know that there will be hundreds of thousands of observations, and we could only take a sample, right? It's just like taking a sample from a large collection of observations. And we have to make approximations based on the number of observations. So how do we take a sample? So we can decide on the number of observations that we take. And I've taken this variable S2 from diabetes database. I've decided to take 30 observations. We can take arbitrary number of observations, and we can decide what is more appropriate. But to start with, we'll take 30 observations. And once we take the sample, this is what we got, right? This is what we have in terms of the number of observations, and we have to make certain approximations to understand where a population mean could be, and what could be a population standard deviation could be. We do not know the exact values, and all we have is the sample mean and sample standard deviation. And with that, we construct something called as a confidence interval. It has a lower end of the value and the higher end of the value, right? So it's the lower value, which is at the lower end of the interval. It's basically stating the lower limit, and the higher value is stating the higher limit. And we have to make an approximation that the population mean lies somewhere between these two. This is the either end of the spectrum, and the population mean would lie somewhere in the middle. So that's the definition of confidence interval. And to do that, we'll quickly calculate the sample mean. We'll also note the length of the sample. We'll quickly construct a data frame to record our findings. Then we create a custom function because we do not know population standard deviation. And when we calculate the standard deviation from a given sample, we have to take that into account. So we have to penalize the value of the sample standard deviation by the fact that we simply don't have enough information about the entire population. And that's why there's the denominator in the formula for standard deviation becomes n-1. And that's why the resulting standard deviation for the sample becomes somewhat broader compared with the actual population deviation. So we calculate the standard deviation for the sample applying the custom function, and then we calculate the lower end and the higher end of the values. And there's something called as t-statistic, which is a kind of multiplying factor, and the scale we apply is the standard deviation for the sample, right? So we're basically multiplying by the t-statistic value with the standard deviation that we calculated for the given sample, and that is basically either added or subtracted respectively from the sample mean to get the either end of the confidence interval. And how do we get the t-statistic value? So it depends on the degrees of freedom and the significance alpha. And there's a table that is typically published for the t-stat values. In this case, we've taken 30 observations. So our degrees of freedom will be 29. And we've taken alpha as 0.05 for 95% confidence. And since this is a two-sided t-statistic, we'll have to look at alpha by 2, which is 0.025. That's how we get the value of 2.045. And that value is used to calculate either side of the confidence interval. Let's look at what those values are. So we have 106 at the lower side, and we have 130 on the higher side. So that's roughly our confidence interval, where we can say with 95% confidence that the population mean may reside somewhere in the middle, right, between these two extremes.